Hi everyone, our lesson today is permutation with replacement, repetition or return, and we have a problem to solve here, and it is tossing a coin. So let's move on. A coin is tossed in the air. Each time the coin lands, we note the head or the tail we get. So how many different outcomes are possible if the coin is tossed 1 time, 2 times, 3 times, 4 times, and 5 times? The first step in solving the issue is to know the number of objects we have. So we have here 2 objects, which is either head or tail, and that is fixed for all these questions, and the number of these objects is n equal to 2. N equal to 2 is going to be used for all these questions. They are not going to change. What is going to change is the length of the sequence generated. So let's see if the coin is tossed only 1 time, we have either head or tail. So we have here 2 outcomes, 2 possible outcomes, and we can write it down as a sample space, head or tail. Or we can also use the permutation formula, but before we use it, we have to know the length of the sequence. The sequence could either be H or T. So the length of the sequence or the size of the sequence is only 1. So in such case, we apply the permutation formula. P and R equal to n to the power of r, and we substitute the number of objects and the length sequence in it, and we get only 2 possibilities. So what is the number of possible outcome? It is the permutation of head and tail of a coin taken one at a time and in order, which is 2 in this case. So possible outcomes are either head or tail. And let's move to the second question. The coin is tossed 2 times, one after the other. So let's see the tree diagram here. So in the first tossing we have either head or a tail, and in the second tossing we have either a head or a tail, and the outcomes are, we have here 4 outcomes. So in the first time we may flip the coin and get tail, and then the second time we may flip it again and get head. So these are the possible outcome, all the possible outcome of the tossing experiment for 2 times, and this is the sample space. So now we divide the mother tree into subtree 1 and 2, and each one has 2 outcomes. We add them together and we get 2 to the power of 2. That's easy. Now let's use the formula to solve this issue, the permutation formula. We have to answer 2 questions. Is there a replacement or not? To do that, we have to imagine the sequence. What the sequence could be? Because it could either be head and head, or tail and head, or head and tail, etc. So we notice that the sequence may have repeated letter here. So H may repeat and T may repeat. So for this reason, replacement is possible. So now we have replacement. The second question is, does order really matter or not? So we have 2 sequential events. The first event, tossing coin for the first time, and second event, tossing the coin for the second time. So order is important, and the reason is tail and head will be counted separately from head and tail. So the condition to apply the permutation formula, both are met, and they are order and replacement. So now we can substitute n and r to get 4. And we can read it as permutation of head and tail of a coin taken 2 at a time and in order, and that is going to be 4 here. We can also use the table and in this table we are going to show the events. So we have the first event, the tossing 1, and second event, tossing 2, and the number of way first event may occur is 2, and the second one 2. So we multiply them together and we get 4. Now we have to know also that to apply this table we need order and replacement in it. So now the coin is tossed 3 times, one after the other, same principle, but there is a difference here we have to pay attention to. So this is tossing 1, we may get either head or a tail, and then in tossing 2, for each possibilities from the first tossing we have again another 2 possibilities, and then for tossing 3 we are faced for each previous possibility we have also another 2 possibilities. So we may toss for the first time and get head, and second time we may get tail, and the third time we may get tail again. And these are all possibilities, all possible outcome of the tossing experiment for 3 consecutive times. So now we are going to know how many outcomes we have by dividing this tree into 2 subtrees. So each tree has 2 times 2, we add them together and we get 2 to the power of 3, which is the permutation formula. N is equal to 2, which is number of objects, and R equal to 3, which is the number of letters in the sequence, in the generated sequence. So here THH has 3 letters, and this number here 3 is the number of letters in the sequence. So we are going now to solve it using the permutation formula. First we have to ask if there is replacement, and we can see that a sequence has 3 symbols, so we may get head and head and head, and each time we see that the letter is repeating, that would imply replacement. So we have replacement, and then we have 3 consecutive events, which means we have order. So a sequence like THH is different than HHT, even though the first sequence has 2H and the second one has 2H, and the first one has 1T and the second one has 1T, but each sequence is going to be counted separately as separate entity. So now we have the 2 events are met, order and replacement, and the last one is the last thing we have to use to apply the permutation formula is R, which is the generated sequence length, or they call it sample point size, which is the number of letters here. How many letters we have? 3, so this is the sample point size is 3, or the number of symbols in the generated sequence is 3. In this case we have to realize that R is equal to 3, which is not equal to N. So the number of letters in the generated sequence is not equal to the number of objects, and it is bigger than the number of objects. As we will see here, R is bigger than 10, and we can still apply the formula PNR for R bigger than N. So here we apply the formula by substituting the number of objects and the sequence length, and we get the permutation of head and tail of a coin taken 3 at a time and in order is going to be 8 here. Now all possible outcome or sample space is written here down. Or we can use, to solve this issue, we can draw this table and we can write all the event tossing 1 and 2 and 3, and for each event we write down the corresponding ways of happening, which is 2 and 2 and 2. We multiply them together and we get all the number of outcomes in order with replacement for this experiment, which is tossing a coin 3 times. Now for tossing a coin 4 times, we are going to apply the same reasoning. So we have tossing 1, 2, 3 and 4, and we are finally going to get all possible outcomes. And then we are going to divide this tree into 2 subtrees and calculate the number of possible outcomes for the first tree and the second tree. We add them together and we get 2 to the power of 4. which is n to the power of r again. So we can also use a permutation formula by permuting 2 head and tail 4 times, and we are going to get 16. Or we can use the table by writing all these events in order and the number of possible happening or occurrence for each event, and then we multiply them together and we get all the possible outcome. Now we are going to toss the coin 5 times, one after the other, and we are going to write down all possible outcomes. So let's use the tree formula. Let's use the tree diagram. So we have for the first tossing and second tossing, third tossing, fourth and fifth. And now we have all these possibilities. We realize that the possibilities are growing exponentially here. We divide this tree into subtrees and we calculate all corresponding numbers of possibilities and we add them together and we get 2 to the power of 5. Now we can solve this issue by using the permutation formula. So we have number of objects is 2 and length of the sequence is 5, and we substitute into the formula and we get 32. 32 is permutation of head and tail of a coin taken 5 at a time and in order. Or we can use the table. We write down all the events in order and all the corresponding way of occurrences. We multiply them together and we get 32. Thank you for watching and have a good day.